is Sean Carpenter, and I was the team leader for the AEV project. My job was to ensure everybody was focused on lab days, that all assignments were turned in on time, and that no conflicts occurred between the group members.
Hello, my name is Madison Hammerberg, and I was the project manager for the team. This entailed keeping the schedule and project notebook up to date. Essentially, I was in charge of documentation.
My name is Oliver Mills. I was the AEV computer designer. This means I created and visualized the designs of the team on the computer in the program SolidWorks.
Hello, my name is Eric Clemenger. I was the efficiency manager for the team. My job was to review each AEV design and code and make sure it was running most efficient as possible.
The AEV project was an extensive process in which each team had to create a hanging vehicle that would run on a track in the lab room.
AEV stands for Advanced Energy Vehicle. The original purpose of the AEV was to create a very efficient way to transport cargo.
For our purposes, we scaled down the AEV so we could create a vehicle and test it in the classroom. We tried to create the most efficient design we could based on the weight of the vehicle.
Our AEV had to complete a track test in which it had to travel down the track and stop at a station. It would then pick up a caboose, which is attached with a small magnet, and return to the station.
A code was created to place on an Arduino circuit board that was attached to our AEV that would tell our AEV when to run the motors and when to stop. It basically controlled all of the functions that the AEV completed on the track.
The Arduino would connect to the computer using a USB cable, and then could be used to program the AEV.
The Arduino board would then be attached with cables to the motor and a wheel count sensor.
In our AEV design, we tried to make it somewhat innovative in the sense that we combined the two black pieces for the arm in order to make a longer arm. This allowed for more variance based on battery charging and differences in the track by making our wheelbase longer and making it so that we could more easily hit the marks. In addition, we tried to make our AEV as small as possible, basically just cramming everything onto a small space so that it would be lighter weight.
For our AEV, we encountered several problems, most notably our Arduino, which was faulty very often, our wheel count sensor, which flat out didn't work at one point, and as well as the track having various inconsistencies throughout the whole entire time. In order to solve these problems, we had to try to get a new Arduino, which very often was not as easy as we hoped it would be, as well as trying to fix the buttons and things that would fall off. For the track, we would have to actually try to take our code and make it so it work more consistently through using wheel counts rather than using time. And for the wheel count sensor, we had to flat out replace that, and we spent a whole entire class period trying to figure out what was wrong.
Each team member created a design of an AEV. Each concept was compared based on weight, balance, durability, cost, and numerous other factors that could affect the design process. Each design was given a score based on each of these factors. The highest scoring AEVs were then combined to create the team's AEV Concept 1.
These pictures were created on the program SolidWorks. Each of the parts available to the teams was created by the professors, and then the teams used the parts to create their own designs on the computer.
The concept of the AEV changed throughout the project. The team went from a vertical to a horizontal design to provide better balance and changed from 2 motors to 1 to give a better weight to efficiency ratio.
This was the final AEV design for our team. It had great balance and center of gravity. It was low weight and only used 68.2 joules of energy on our final run.
Here is our AEV performing its final run. You can see the completion of each task discussed at the beginning of this video.
Our final AEV design completed the track testing with 2 perfect runs, hitting all of the marks and stopping for the desired times. Our team is very proud of this accomplishment and considers our AEV a success.
This graph shows the efficiency of our AEV over the time it ran on the track. The energy used is shown here.
Overall, this project is a great way to learn about teamwork and the engineering design process of brainstorming, testing, assessing, and making changes.
We would like to thank the Ohio State University Department of Engineering, our professors, GTAs, and UTAs for making this project possible.
Do something! Hey, Scungili! Got it!
Why, hello there.
Yeah, go ahead.
Essentially, I was in charge of documentation.
Are you? Well, that's fantastic.
We're innovative.
The end.